In this video, we're going to go over how do you solve a nonlinear system by graphing. So the first question is, how do you know the number of solutions for a nonlinear system? And it's all based off of intersection points. So for example, we might have something like this. We see two intersection points, and so we see that we have two solutions. We might have something that looks similar to this. Notice we have one intersection point, so here we'll have one solution. Or we might end up with something similar to this. Notice that those lines don't ever intersect, so there'd be no solution. So what are the steps to finding the solutions of nonlinear systems? Well, first, you want to graph each equation. Then, you want to find where those functions intersect. So how can you use the calculator to help you with this? You go to y, for graphing the equation, you go to y equals, enter your equation, and then hit graph. And if you need to, hit zoom 6, and that kind of puts it to a 10 by 10 window. To find where they're intersected, so for step 2, on the calculator, hit second, trace, then the fifth option. Then get close to your intersection points. And we're going to go through some examples. Let's start by looking at some graphs that we already have graphed for us and how we can determine the solutions. So if we look at letter A, we see that we have two solution points. So there's two intersection points. Using our graph, we can see that those are located at approximately -2, 0 and 1, -3. And those would be our two solutions to that system. For letter B, we see that those functions never intersect, which tells us that we're going to have no solution to this system. Go ahead and try letters C and D on your own. And when you're done, push play and let's see if you were right. For letter C, we have one intersection point happening at 2, 2. For letter D, we have two intersection points happening at -1, -4, and 4, 6. Now let's try graphing some examples. So here we have y equals 2x squared plus 5x minus 1 and y equals x minus 3. So we'll pull up our calculator and we'll plug in our equations. So we have 2x squared plus 5x minus 1. Oops. Let's try that again. So y equals 2x squared. I must be hitting something. All right, let's try this one more time. 2x squared plus 5x minus 1. And we have x minus 3. So we'll hit graph. And we see that that's what our equation looks like. So let's sketch that really fast. All right. So we're now ready to calculate it using our calculator. So we're going to go to second, trace, and we're going to choose option number 5, which is our intersect option. And now we want to get close to the intersection point. So I'm going to get kind of close. I look like I'm right on it almost. So I'm going to hit enter. So that's the blue equation. And then my red equation, so the second equation. And now it's asking me guess, because when we're finding our solution by graphing, it's an estimate. That's why it says guess. So we're going to hit enter again for it to calculate that. And here we're going to see that we have a value of about -1 and -4. So we're at about -1 and -4 as our solution. Let's try letter B. So again, we're going to go to our y equals. We'll plug in our equations, x squared plus x minus 1 and 2x plus 3. And we'll graph those. And we see two intersection points, so that tells us that we should expect two solutions. So we'll sketch our picture. And now we're going to go same thing, second, trace, option number 5. Now there's two intersection points. So we want to be close to our intersection points. So we're going to start over here. So the first equation, the second equation, what is my answer? And we get about a -1.6 and about a negative 0.13. So our first solution would be a 1.6. Oh, no, kind of went a little bit haywire there. Let's check this again. Nope, just need that negative sign. There we go. And now we're ready to calculate our next one. So we're going to go to the same thing, second, trace, option number 5. And now we're going to get close to our other intersection point. So we're going to go ahead and move over to that intersection point. And we'll hit the first one, our second line, and to guess it, and we're going to get about a negative 2.6 and an 8.1. And so we're going to have a solution of negative 1.6 comma negative 0.1 and 2.6 and 8.1. Let's do letters C and D. So we'll pull up our calculator again, and we'll put in our equations of x squared minus 3x minus 2 and negative 3x minus 8. When we graph that, we see that we have equations that don't intersect, which tells us that we have no solution here. We have no solution. Let's go ahead and do our last example together. So we'll pull up our calculator and we'll input our functions of x squared minus 2x plus 1 and x plus 1 and graph those. And so here we see that we're going to have two solutions. So we'll sketch our diagram, sketch our graphs, and then we'll go to second, trace, option number 5, and then we're kind of already really close to that intersection point. So our first line, second line, and the answer here is at 0, 1. So do the same thing for our other intersection point, choosing option number 5. We'll get close to the other intersection point and go our first line, second line, and the answer here is 3, 4. So we've got answers of 0, 1 and 3, 4, and those are our solutions. And so that is how you can solve nonlinear systems by graphing.